All right. Hello, everyone. Thanks for coming to attend this session. I'm Poonam. I work in the JVM Sustaining Engineering Group at Oracle. And in this session, we are going to talk a bit about the new GC logging format that's coming up in Java 9. The mandatory slide that I have to include. So new GC logging in Java 9. It's a big change, massive change that's coming in Java 9. Actually, it follows another major change which is being introduced in JDK 9, which is Unified JVM Logging Framework. So GC logging would be using this framework, new framework in JDK 9 to log its messages. And in this session, we are going to talk about, a bit about Unified JVM Framework, GC logging, the new command line option that we need to use to, to see equivalent information that we used to see with earlier JDK versions with the GC logging options. Here's what I'm going to talk about, Unified JVM Logging Framework, new in Java 9, how GC GC logging code is re-implemented to use that framework, new command line option -Xlog, which is actually added by the framework, and GC code has introduced new tags to be used along with this command line option. What configurations we need to use with this command line option to get the equivalent information in the GC logs. What happens to the old GC logging flags, we'll see, and then take a look at some of the examples. Unified JVM Logging Framework, JEP 158 was the proposal. To add this new enhancement, to add this new framework into JDK 9. It adds a new command line option -Xlog. And with this, there are some tags added into various parts of the JVM, representing different parts of the JVM that can be used along with this command line option to fine-tune the information we want to see in the logging. For example, GC, class, JFR, modules, etc. And these logging messages coming from the framework, whichever all the systems using this framework, we can use tags to categorize these logging messages. It's possible to use a combination of tags with -Xlog, a set of combinations of tags to really select the messages which we want to see in our logging. And all the loggings can be done at different levels. There are certain levels defined: error, warning, info, debug, trace, and develop. Develop is for non-product builds. The other levels are available in the product builds. And the messages can be decorated, which means that there are certain decorators available which can be used to enhance the message. You can add additional information to the logging message. The default decorators are uptime, level, and tags, but you can, of course, change the decorators that you want to see with your logging messages, and it's possible to redirect logging to a file. So all this is done under the Unified JVM Logging Framework. The help option can be used with -Xlog. And it provides information on the complete syntax of the command, how you can use it, what are the options that can be used along with -Xlog. So the most important thing to note here is the what which it comes after -Xlog : what is the combination of tags and the levels for which we want to see information coming from different components of the JVM. Note the star or the asterisk which follows the tag sets. It denotes a wildcard, which means that I want to see the logging messages which are associated with the superset of the tags that I am specifying on the command along with -xlog command. So I would like to see messages that are tagged with at least these tag sets, but they may have other tags as well associated with them. Let's take a quick look at the other options that can be used with -xlog. You can change the output, using the output option, whether you want it to be redirected to stdout or you want to redirect it to a file. The decorators, time, uptime, time millis. So these decorators enhance or add the information to the logging messages. As I said, uptime, level and tags are by default enabled, but you can remove them or change them. And the output options are basically to to enable or disable the log file rotation, or to specify how many log files you want to be rotated and what is the size of each file, log file you would be interested in. Now, unified GC logging. So with JEP 271, GC logging has also been re-implemented to use the new framework. So GC uses -xlog command, and GC is the main tag to be used with -xlog, and there are other tags as well, available for fine-tuning the GC logging that we are interested in. And the old GC logging options, it might come as a shock, will be removed in JDK 9. So, if your launch scripts or your command line options are using the old GC logging options, they will have to be removed when you move to using Java 9. 8145092 was the bug ID under which this enhancement was integrated into the repository. So if you are interested in looking at specific changes that were done for re-implementing GC logging, you can see the changes done under this bug. Let's take a look at the example output that we would see with the -xlog GC. So here I am specifying that I want to see messages, log messages that are tagged with GC tag and are logged at level trace. And if we specify a particular level, the messages below that level are also logged. So in this case, messages logged with trace, debug, info, error, and warning would get logged. So in the output, we can see that all the messages that are tagged with GC are printed out. The first 3 columns come from the logging framework, and they are uptime, level, and tag. And the rest of the message is coming from the GC code, code in the JVM. What happens to the old GC logging flags? As I said, they will be removed. They have been removed in the repository, but we still retain 3 most popular flags: print GC details, and Xlog GC. They won't be showing you the old output, but they have been internally mapped to the corresponding Xlog configuration, so that at least for these flags you don't have to update your launch scripts and the command line options. They will show the new output, but they are still honored. You won't get a error message and that the JVM itself doesn't launch. These flags are deprecated, and will be removed in a future Java release. So all in all, 43 GC logging flags are removed with this change. Here's an example of GC logging code change that went in as part of this re-implementation. So if you see earlier we had under print GC details, we had GC log or TTY, and it invoked function print to send the logging message either to a console or to a logging file. It has been replaced with log underscore level macro, and that macro is implemented in the logging framework. So this macro, what does it do? It, you know, there are different macros for each level, and here you are telling that I want to log this message, which is heap usage transition details with tag associated with tags GC and heap, and I want to log this message at info level. So if someone on their command line uses Xlog colon GC plus heap is equal to info, or you don't have to say info because that's the default level, then this message would get printed. Another example, we used to have a flag print adaptive size policy, so that has been removed, and a logging message at trace level is logged using tags GC and ergo, and the message remains the same. Some examples, so I have tried to use, since G1 garbage collector is the default in JDK 9, so my examples are using G1 with JDK 8 and the default collector in JDK 9. So this example using the old flag is with the JDK 9, and on the next slide I will show you the example of the output with JDK 9 using G1 collector. So here we can see this is the usual output with print GC option. To get the equivalent information with the new logging framework in Java 9, we would be using -xlog colon GC. So print GC, if you are using print GC, it will be replaced with the -xlog colon GC. It gives the same same level of information, and the additional information comes from the framework that these are the tags and this is the time at which this event occurred. Print GC details, again with the G1 collector with JDK 8, this is the information that we used to get with print GC details. In Java 9, we need to use -xlog colon GC star. So by GC star or asterisk, we are saying that please log messages that include at least GC tag in them, and they may have other tags associated with them. So if you notice with print GC details with G1, you can see the phase level information here. The logging messages giving us information about different phases of G1 garbage collector. But with Xlog colon GC star, that information is missing. So with other collectors, you would get the same level of information with the -xlog colon GC star. But with G1, we need to use GC plus phases is equal to debug to get the phases level information, because that information is logged under GC and phases tag, and that's logged at a debug level. So as to keep the detail level separated from GC star, and you need to specify additional tags to get more detailed level information. Print heap at GC, which using which we can get the heap usage details before or after a GC. For that, in Java 9, we would be using -xlog colon GC plus heap is equal to debug, which means log, print the log messages tagged with the GC and heap and, at debug level, being printed at debug level. We have options print GC application concurrent time, print GC application stop time in JDK 8, which are used to print the application runtime and application stop time. In JDK 9, we would be using -xlog : save point. So with this tag, the application runtime and application stop time, the same kind of information, same level of information would be available with the save point tag. Print adaptive size policy, which prints the heap sizing and the collection set construction decisions being made by the collector. In Java 9, we use GC plus ergo star is equal to trace. So GC and ergo plus some other tags, messages at the trace level. Print enduring distribution, which used to print the survivor size or the age distribution of surviving objects in the survivor spaces. So for that option, we would be replacing it with -xlog GC plus age is equal to trace. So it gives the, even the text remains the same, it gives the same information. So we had -xlog GC option, we still have -xlog GC option up until JDK 9. And that's used to redirect the logging output to a file, and we could use options, use GC log file rotation to enable the logging file rotation, and this is how those options could be used to enable rotation, logging file rotation, and to redirect the output to a file. Even though this option would still be there in JDK 9 -xlog GC, but the rest of the options will be removed, and xlog GC would be mapped to -xlog GC, :file is equal to the name of the file. So this is how we can redirect the output to a file, and we could enable file rotation and specify the number of files we want in use and what should be the size of each file. So other useful tags to get more information and details about -xlog command. If we use -xlog : GC star is equal to trace, so that prints the lowest level of information, of GC logging information. So trace is the most detailed level to be specified, and GC star means include all the GC related options, all the GC related tags in the output. So this provides the, all of GC logging at the lowest level. And -xlog all is equal to trace, which means I want to see GC logs from all the subsystems of the JVM at the lowest level. And it is possible to disable the logging altogether using the disable option with -xlog. And as I said, help provides the syntax and examples for -xlog command. And -xlog logging is equal to trace actually gives, enables tracing for the logging framework itself. So it provides information about the available tags implemented by the system, what are the available tag sets, what are the available levels and decorators, and what's the active configuration of available tag sets. Is it possible to dynamically configure -xlog? Yes, it is. We can use J command or mbeans to dynamically change the options of -xlog. If we use vm.log with jcommand diagnostic command, it shows what are the options that can be used to configure the parameters of -xlog. And for here in this example, I am using what is equal to GC star, which means I am changing the tags that can be used with -xlog to GC star. So I put together, these tables mapping the old GC flags to the new Xlog configurations that can give us the equivalent GC logging information which we used to get with the old flags. So for example, print G1 print heap regions, which is available in JDK 8. In JDK 9, we can use xlog :gc plus region is equal to trace. So by looking at the code, by running some tests, I prepared these tables mapping the old options to the new configurations. So maybe you can refer to these tables later on when you are migrating your applications to Java 9 and updating your launch scripts. So with that, I come to an end of this presentation. Thank you so much.
I liked your table. Can you include that in the release notes?
This, I will be uploading it somewhere, so this will be publicly available. Yes?
One thing I've hit in the past is if disk is having issues waiting for the GC log to be written to disk, that can actually impact the application. With the new unified logging, can you have that run ASAP?
I'm not aware of that. Yeah. Yes.
So I'm not complaining, but why did you actually remove the previous flags and you didn't make them like knobs and deprecate them?
I guess that we did with the 3 popular flags, but it would have been having so much redundant code and maintaining it in the code base would have been difficult. So.
You just have, you don't use them. You just have them just say they are knobs, they're deprecated.
And they don't do anything?
Yeah, just so that. Yeah, they just ignore, just so that some.
At least JVM.
And it's not just like those 3. And it would be nice if basically you didn't immediately crash, at least for 9, if you remove them in 10.
But wouldn't that let the users have garbage in their launch scripts? They would never remove it.
Some users aren't controlling the launch scripts. Yeah. Some of them are launched by other Java processes, and you specify the command line to the Java.
You can't use ignore unrecognized.
Again, only if you can have access to the command line. So you may not have access to the command line.
Yeah, but being in sustaining, I have seen that you're saying that people are not in control of their launch scripts. If you take a look at some of the launch scripts, they are full of trash. People don't know where those options are coming from, and if this is allowed, you will have all the junk accumulated in the launch files.
Exactly, they don't know where those options are coming from, so they don't know where to remove them.
So this will force them to remove it, which is garbage should be removed. Anyway, in future, if we deprecate it now and remove it in future, anyway, at some point you have to remove it, right?
So actually, well, traditional one is deprecated in one release and then moved into the system. So this is kind of a departure from the norm. That is why.
Right. And anyway, these options, we say that these are unsupported and we don't, we can remove them anytime we want. And coming back to your question that don't do anything, just let them be there. If we just let them be there, you would expect the output. When some failure occurs, you would say, oh, I had these options on, why don't I see my log file? And why don't I see something in my log file? You won't. because then why didn't you tell me that I had to remove it?
You will see a warning saying you should have.
Nobody reads warnings. They are just, the process has started. You never read what is being printed on the console.
Can you go back to the code example for now? We showed the log with a couple of tags.
The coding change.
Yeah.
Yep.
Yeah. So the GC and Urkel, basically, what does log trace GC Urkel return? Is it a stream? Is it something that basically encapsulates is this a function query?
So this is a macro. We have log underscore info, log underscore trace. These are encapsulated macros, and that the macro is defined as log underscore level, which actually then blows into these different macros for each level, right? So. So this macro is accepting the tags, and then it calls a function, passing it, the specific function for that level and encapsulating this message.
What I'm interested in is getting access to the predicate where that particular level of that particular tag is enabled, plus the stream at which it's being directed to.
It's-
Check if that's enabled.
Okay.
Yeah. So this macro would actually check, if this level is enabled or not, and then it logs the message.
You can check explicitly because maybe you want to do some calculation. Well, I think what John is getting to is you might want to do some calculation before you write something, but you only want to do the calculation if that level is enabled. And
So
there's a macro to check.
yes, so this macro log underscore trace will actually check.
No, but what happens if you want to check beforehand?
So this actually expands to the code, and which is a check.
But the problem I'm seeing is, for example, is the previous thing was just a Boolean. So you could pass that into an RAII type of object, take the thing inside the C++. I don't think you can pass the result of this into an RAII type of object.
I don't know.
So one of the scopes, like mutex locker.
Right.
That's an RAII object. And okay, we can take this offline. I may send an email with this.
Okay, yeah.
But yeah, the two things I need access to are the predicate plus the stream.
Okay, all right, yeah. I'll get in touch with you regarding that.
We'll take this offline.
Yeah, sure. So yeah, get ready, be prepared for this new logging format in Java 9. Thank you.